Alright, so in this video we're going to look at how to make a couple different types of other waveforms. Like we looked at the sine wave in the previous tutorial. I talked about some other types of waveforms and we're not necessarily going to use them in this class, but I still think it's useful to show. So for example, if I wanted to create, I keep doing this. If I wanted to create a square wave, for example, I can do that by using a voltage source. And I can call this, I'll call this V square. Okay, and we would come in here to our advanced settings and we would go ahead and click pulse. And let's just say we want this thing to swing between -1 and 1. So I'll say -1 for V initial, 1 for V on. And then as far as the time delay goes, we can just set that to 0, not necessary. Our rise and our fall times in order to create a square wave need to be much, much less than our period and our on time. Okay, so let's just make these something super small, like 1 nanosecond. And for our on time, if we want to make a, let's say we want to make a 1 kilohertz square wave. Actually, you know what we're going to do? Let's make our parameters. I haven't talked about parameters up to this point, but I think it would be useful to show at this point. So what we're going to do is we're just going to say in curly braces here, let's make our on time 0.5 times my period t. I'll call that. And then for my period, I'll just make it t. Okay? And so remember, you have to put curly braces if you want to use a variable. I'm going to go ahead and show you what we can do now in order to fill in this variable so that we can make a square wave of basically any time or any frequency just by editing some variables rather than me having to sit here and change these every time. So now if I hit spice, I can type what's called dot param, and I can just name a variable. Let's just call it f for frequency, or I can even say frequency equals, and let's just make it 1 kilohertz. So I have this parameter now. My frequency is equal to 1 kilohertz. That's set by me. I can also create another parameter now, and I can calculate my period t, and I can say that it's just equal to, and since I'm doing a calculation here, I have to do curly braces again, 1 divided by my frequency. Okay, and so now that is going to set my period based on the frequency. So I've just set t to be 1 divided by this value, which is 1 kilohertz. So I'm going to get 1 millisecond here for my period, and I'm going to get a half a millisecond for my on time. So this is going to be a 1 kilohertz square wave, okay? And so if we want to view 3 cycles here, let's just run for dot tran 3 times my period. Okay, so 3 cycles. And this is going to be really useful moving forward that you can do this. So let's create our square wave now. I'll go ahead and hit run, and let's take a look at what my signal looks like. And there it is. There's my signal swinging between 1 and -1, 3 times in 3 milliseconds. That's my 1 kilohertz signal. And of course, you can come over here. You can change this to 1.5 and -1.5 if you want to be able to see the top and bottom of the signal. We can always change the color so that it's more visible. And so there's my beautiful looking 1 kilohertz square wave. Okay, what if we wanted to create a triangle wave? How would I create a triangle wave? Well, there's a couple different ways that you can create a triangle wave, but the way that I would do it is I would take a pulse source just like this, and instead of making really fast rise and fall times, let's go with V triangle or V tri. Instead of making really fast rise and fall times, I'll just make my rise and my fall times equal to the length of half the period, so that it comes up in half the period linearly and down in half the period linearly, and that will give me a triangle wave. So if I wanted to do that, I'll just make my rise and fall times also equal to 0.5 t, and then I'll make my on time something really short. Okay, I don't even know if I have to, since it's constrained by the period being t. I might not even have to mess with this. Let's just see if I leave it alone what happens. Let's run that. Let's see what this looks like. Oh no, yeah, it's not working out. It's the on time definitely needs to be changed. So let's make the on time something really short, like a picosecond, so that it just doesn't even stop at the top. And there's my triangle wave. Okay, so me add a plot pane here, and I'll just throw my triangle wave here. So I'm swinging between -1 and 1. Now I've got a triangle wave there, and hopefully it's clear what I just did. I basically just said I want this thing to repeat every t seconds, so every 1 millisecond, but I want it to take half a millisecond to rise from -1 to 1, and half a millisecond for it to fall from 1 back down to -1. And so that's exactly what I've got here, is this triangle wave. And so what if I wanted a sawtooth wave, which is the other type of wave that we saw? I'll do this last source here. Let's just copy this, and let's say vsaw. Okay, and let's say we want that to be at 1 kilohertz. Well, if I wanted a sawtooth wave, all I would do is I would make my period almost equal to my rise time, and I would make my fall time incredibly tiny, something like 1 picosecond. And so now what it's going to do is it's basically going to ramp up in the entire time it takes for a period, and it's just going to sharply decrease back down and do that again. So let's go ahead and run it, see what my sawtooth looks like. We'll add a plot pane here, look at our sawtooth, and there it is. Okay, so we've created a sawtooth wave, a triangle wave, and a square wave, all using the pulse sources in LT Spice. And I think it's really nice to use these parameters for parameterizing things, because now if I wanted to, and I still want to run it 3 cycles, but I want to change my frequency to something like 10 kilohertz, I can do that and nothing's going to change, right? The only thing that changed is my x-axis. Now instead of 3 milliseconds, it's 300 microseconds because I made my frequency 10 times greater. My signals all look identical. Okay, so parameterizing your signals is always a great idea. If you have any questions about this, please feel free to let me know. But I'm going to go ahead and end this video, and we'll see you guys in the next LT Spice tutorial.